Hello and good day, geometry. We are continuing on with CO2, where we're introduced to our first postulate. Okay, I mentioned before we started to record that we will have postulate and theorems quizzes. These are basically the quote-unquote vocab terms for math, for geometry. But in reality, they are the reasons why we can do what we do. When you solve an equation in algebra, which you've done several times before, you were using properties and postulates and theorems. I didn't explain it like that. I said use opposite operations, railroad tracks, or whatever. But the reason why you can do that comes back to these postulates and theorems and properties and definitions and all these things that we're going to be talking about. So I advise you to keep kind of a running log of all these things. At the very least, identify them where they are in your sheets so you can easily find them. But just like you study for a vocab test with flashcards or science test with flashcards, you might want to make flashcards for these things too. But how you study best is up to you. Okay. But anyway, we're in geometry, but we're already using algebra. We're using algebra to find segment length and determine if two segments are congruent. What does the word congruent mean? You've seen this in your math packets since the beginning of last year. Gino? Not quite. Not quite. You're close, but there's a minute difference. Mackie? The same. Okay. Congruent, in our purposes, is going to mean the same size and same shape. Okay. Same size and same shape. Okay. And so the difference between saying they're equal is that when you say something's equal, you're saying it has value. You know, if I draw two congruent circles, not too bad actually, same size, same shape, they don't have any value, right? So to say that they're equal is not quite correct. Okay. If you have two quarters, you know, they might be equal but not congruent. One might be more worn than the other. It might be a different state or different year or whatever. But they would be equal in value. So there's a difference here, and I kind of get into it in the second part here. If we're talking about the lengths of two segments, we can say their lengths are equal because it's a value. You can measure it. You know, if this is 4 centimeters and this is 4, they're of equal lengths. When you say segments are congruent, saying they're the same size but don't assign a value, you use the congruence symbol, which is like the equal sign with the little wiggly thing over it. Okay. Also notice when we're talking about length, we don't put a label above A, B, and C, D. Okay. That's how you know it's talking about the value of it. Versus with congruent to, we've got those lines above it. Segment AB is the same as segment CD. Its value is equal to the value of CD. All right, so we'll come back to that, but that's essentially the gist of the difference between equality and congruency. Yeah? Yes.
How do line segments become like the same shape?
They're the same shape in that they're both segments. You know, you could have congruent segments that one goes horizontal and one goes up like that, right? If they're congruent, it means they're the same size. They're both segments. And then when we assign value to them, we say this has a value of 6, that is a value of 6. Now we can say they're also equal value. If two things are congruent, they are equal, but we can't label them equal until we know what their value is. Yeah, so the congruency marking for a side length or a segment length is that line going through the center. Okay, that's kind of the labeling for congruency. All great questions, Drake. Thank you. Anyone else have labeling questions? Blake?
When they're doing lines, it's like that. What do they do if there's like two that are the same and another two that
Good question. If we've got a rectangle, and we know based on the properties of a rectangle that the opposite sides are congruent, right? So to say the bases are congruent, we might use one mark in the center. To then say the other two sides are congruent to each other but not congruent to the bases, we'd use 2. And if there's a third, we use 3, right? So you just keep adding marks to show that those two are congruent but different lengths than the other ones. Great questions. Good stuff. Anything else? Does make sense. Turns out math makes a lot of sense. Okay, so the segment addition postulate, I'm going to scroll down a little bit here so we can kind of work on this section here. The segment addition postulate states that a segment is equal, this is going to be earth-shattering news here, a segment is equal to the sum of its parts. The segment addition postulate, it says that a segment is equal to the sum of its parts. Okay, so for example, if we have a segment here that is labeled A, or I should do, sorry, I should put the A in the right spot, shouldn't I? Okay, A, and then here's B, and then here's C. Okay, we have 3 different segments here, right? We have segment AB, which is that short piece. We have segment BC, which is the longer piece, and we have segment AC, which is the whole thing. Follow me? Okay. The segment addition postulate, and this will be earth-shattering news here, but the segment addition postulate says that the length of AB plus the length of BC is equal to the length of AC, right? The length of the part that goes from A to B plus the length of the part that goes from B to C is equal to the length of the whole thing that goes from A to C. You already know this kind of stuff, right? But this is the reason why it works, okay? If someone were to ever challenge you on this and you whipped out the SAP, that's what we call it in my geometry club, the segment addition postulate, they couldn't argue you, right? There's no arguing this, okay? We can also use this to say that AC, which is the whole thing, right, minus BC would be equal to AB, right? The whole thing minus part of it equals the other part of it. What's the other kind of fact family we can write here involving these 3 parts? Yeah. AB, I think you mean the other way around. AC minus AB equals BC, right? The whole thing, AC minus the large part, is going to equal the smaller part, or the whole thing minus the smaller part is going to equal the larger part, okay? Those are basically all the relationships that we can get from this segment. So when you solve this, most of you probably have by now, right? What's the length of segment GH? Raise your hand if you have it. Gino? 15. I challenge you, Gino. Prove it's 15. Why is it 15, Gino? Why is it 15, Gino? You win, Gino. Yeah, you win. Okay? We know that the sum of those 2 parts has to equal the whole thing. Okay? Essentially, you just solved the equation 21 plus x equals 36. Right? 36 is the whole. You found one of the parts. When one is 21, the other part has to be 15. You were doing this when you solved equations back in 5th grade. You just weren't ready for the SAP yet. I think you are now. Some of you might not be, but some of you. What's the length of WX? Raise your hand. What's the length of WX? Caleb? Prove it, Caleb. That's right. Okay? Because 37 plus 107 equals 144. Blake? If that's what you use to get the answer, yes. And you showed a little bit of work behind it, but yeah. I mean, the answer to every math conundrum is not SAP. There are others. You know, if it was all, if it only came down to SAP, it'd be a very small binder, right? But there's more stuff. Mackie.
So look at the wall and then put your hand behind your back and try flipping.
I'm not great at multi-step equations. What? Look at the wall.
Yep,
Okay.
and then take the marker and put it behind your back.
Okay.
And flip it 3 times in a row.
You want me out of here, don't you? You want me out? Why, Mackie? Why would you say that?
You get 10 tries.
I can't even. I don't know if I can even flip it backwards. That's just. That's only one. No, I'm not going to do that. Okay. All right. Questions so far? Really? What?
It's quite the sappy moment when I'm wearing sap.
Yeah. Yeah. Okay. Going on. Now, this is a high school course, and so it does get a little more challenging than what we have there. Okay. Here's what you can expect on your test, something similar to this. It says point B is between points A and C. So let's just start there. Okay. Geometry is a very visual branch of math. If point B is between A and C, let's draw point B between A and C. It does not tell us where in between. We don't know if it's right in the middle. We don't know if it's closer to C or closer to A. That doesn't really matter. Let's just draw a segment AC with point B somewhere in between. Okay? Now we're told that AB, the value of AB is 2x plus 7. Okay? BC, the value of BC is 7x minus 8. And the whole thing from A to C is 80. Now, when we label this 80, you might see it written in a different color than the AB and the BC, and you'll see it more in the middle. So if you were to see a diagram such as that, that would show that the whole thing is 80, different color and in the center. Or you could also see something like this, right? Where it's showing you that from A to C, that entire section is 80. And our task is to find the lengths of AB and BC. Put your algebra caps on. What are we going to set up? That's my first piece of merch, algebra caps, once I hit 200 subs. What equation can we set up here that's going to allow us to solve for A, B, and B, C, really just using the properties of SAPA? Sorry, what? Shh. Well, we don't know for sure that 2x plus 7 is equal to 7x minus 8, because like I said, we don't know if point B is in the middle. All it says is it's between. If it said in the middle of A and C, then yes, we could. We could say those two sections were equal, but we don't know that. So what can we set up instead, Peter? Yeah, based on, Mackie, based on the SAP, we know that these two parts, 2x plus 7 plus 7x minus 8, has to equal the whole thing. And there's your algebra equation to solve. Okay? Combine like terms, do the thing, do the other thing, and you can solve it. Okay? You can combine like terms, 2x and positive 7x, that gives you 9x. And then you have positive 7 and negative 8, that gives you negative 1. So we can rewrite this equation to be 9x minus 1 equals 80, and I think you can solve it from there. Okay? X equals 9. Is that the answer? No. I guarantee some of you will make this mistake on the test because you're not paying attention right now. You're going to solve for X, you're going to circle it, and you're going to move on to the next one. Okay? Gino, warning for you on that one. Okay? I'm all up for fun and games, but not for that. Your task here was to solve for or find A, B, and B, C. Now that we solve for x, what do we do with it, Drake? Right. Right. Now that we know what x is, we can plug it into our expressions up above to solve for the length of AB. 2 times 9 is 18, plus 7 gives us 25. 7 times 9 is 63, minus 8 is 55. The nice part about this is that checking these is really slick, because what should A, B, and B, C add to equal? 80. Do they? Yes. Right? So it's a really nice way to, if you did solve for x incorrectly and plugged it in, it wouldn't work out. Okay? Yeah.
What if they don't equal 8?
Then you did something wrong. You set up your equation incorrectly. You solve for x wrong. Geometry also is it's very easy to check your answers here, because you've got multiple ways to do it. Yeah.
Would it be bad to guess and check if you?
Guessing and checking is always an option. However, the downside of that is it's not very efficient. Okay. There will be tests that you take where there is a time limit, and that is it. It's not come in for lunch the next day. It's not stay after school tomorrow. It's your time is up. And so if you go through it just guessing and checking, you might get half of them right, but then you run out of time and then you get a 50%. So knowing the process is usually much more efficient. So that's always recommended. But in a pinch, guess and check is an option as well. Next one, it says point B is between points A and C. So similar setup here. We've got A, we've got C, and point B is somewhere between. It says AB is 6x plus 12, so we're going to label that distance 6x plus 12. BC is 29. And AC, the whole thing, is 19x plus 15. So again, you might see it like this. That 19x plus 15 is in the middle, more or less. What equation can we set up? Not yes or no, but not can we, but what equation can we set up? Which equation? Some of you haven't heard from me yet today, perhaps. Let's get a new voice. Fresh participation. Sydney. Great. 6x plus 12, which is one part of the segment, plus the other part of the segment, 29, has to equal the whole segment, 19x plus 15. Okay. Again, we can combine some like terms here. There's really only two that we can combine on the left side, 12 and 29. So that makes it 6x plus 41 equals 19x plus 15. And now I've got variables on both sides. Okay. So you might want to move your 6x's over to the right by subtracting them. That will give us 41 equals 13x plus 15. Move your 15 over by subtracting it. 26 equals 13x. And we get 2. That's not our answer, though, right? Because the original question said, find AB and AC. AB, 6 times 2 plus 12 is 24. And from here, you could kind of take a shortcut and say, 24 plus 29, that's 53. That's got to be the length of the whole thing. But it just make sure, check yourself, 19 times 2 is 38, plus 15 also gets you to 53. How are we doing so far? How can I help? Oh, okay, good. Okay. Last thing we're going to do in class today, it says draw segment AF that includes points B, C, D, and E in between and in that order. Please do not draw this small. Let's stretch it out a little bit. Actually, I'm going to lower mine so I can write on both above and below the segment. Okay, so here is segment AF. and points B, C, D, and E are in between in that order. Okay? I'm going to use this first clue just to help me put these in a somewhat reasonable spot. I'm told that AC is congruent to CE, right? So E is the point that's closest to F over here. I know that point C is halfway between A and E. That's how I can conclude that AC is congruent to CE. So I can at least get it reasonable positioning here, because I know that the points go in A, B, C, D, E, F order. And if AC is congruent to CE, that means that point C is between A and E, right? B and F, I don't know where they go. I'll put point B, or sorry, I know where F goes. A point B there, we'll put point D here. Maybe that's accurate, maybe it's not, but at least it's in between where it should go. Your job is to find the lengths of all these different segments here, given some of the clues that we have. So we know that AE is 50. Okay? Does that help us at all? How does that help us? Blake? Sure. Okay, we know that AE plus EF equals AF. We would know that even if we didn't know that AE was 50. So the fact that AE is 50, we're given that value. Can we find any of these segment lengths? I mean, we don't have to find AE as part of our list over here, but knowing that's 50, what can we conclude about other segments? Joey?
So since A to C and C and E are the same distance, and A to E is 50, then AC and CE is 25.
Bingo, right? If AC and CE are congruent, meaning they're the same, and AE is 50, that means from A to C, I'll do it in green, from A to C and from C to E, both of them have to be 25. Now you got to be kind of careful how you label this, because of this many numbers, it's easy to kind of lose, wait, what was that 25 for? So I'm going to be erasing these as I go along. You might want to do the same, or however you want to organize, it's fine, okay? But we can solve for AC and CE. They are both 25. Okay? From C to F is 35. Okay? So just to kind of help visualize things, C to F is 35. That 25 went from C to E. Is there any other segment piece I can solve for here? Michael?
If A and C and C and E would be 50,
Uh-huh.
then E and F would be 10.
Right. If from C to E is 25, and from C to F is 35, well, this is the SAP, right? What's that missing piece? It's got to be 10. Okay? So that's kind of the thought process that you have to have here. Use the given information and then fill in those missing pieces. Yeah. Also then, AF would be 60, right? Good. Because if A to E is 50 plus an extra 10, we can now solve for the whole thing. Excellent. Okay? So that's the kind of geometric logical thinking here, right? Questions on this? Drake.
So when you add that, so like AC, CE, EF, and DE, and all those ones, do they all have to add up to 60?
So each piece, AB plus BC plus CD plus DE plus EF would add up to 60.
What about like it wants us to find all of them? Do they have to add up to 60, or do they go?
Oh no, these all won't add up to 60. No, because they're including, multiple sections of AF several times. Yeah. But each individual section, when you're all done, should add up to be 60. Okay. Your other homework is going to come from the book. So on that keep calm and do your homework line is where I will write this. So you'll need to bring your book home if you haven't already. It is going to be on page, oh boy, I haven't assigned homework from a book in a long time. This is fun. On page 12. Seems like a good place to start. I would like you to do 6 through 12, comma, that means there's more. 21 through 26, nope, 27, comma, 28, 30, and, oh, I saw I could have done that, and 36. I like to keep you on your toes. What you going to do next? Who knows? Really, it's only 13, 14, it's only 15 questions. 16 questions. So Schlafer asks a valid question. Where do you put your answers? You have to put them right below the homework line. Here. I'm kidding, Schlafer. You can do it on the back side. These sheets are single-sided, so you can just use the back side for book homework. Or if you want to keep a notebook and do it in your notebook, that's fine also. Okay? So either a notebook or just the back side of this page, you can put your homework answers there. All right. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Remember, folks, whenever you say I assigned too much homework, this is technically a 10th grade level course. So Peter?
Congratulations.
Thank you, Peter. I don't know for what, but I appreciate it. All right, folks, that's how you math.